Hello, everybody. How's it all going? So thanks for joining me today. I'm just going to share my screen for yourselves. Hello. Just give you a few more minutes just to get all on. And a very good afternoon, everybody. And thanks for joining me today for this Pix4D webinar, where I'm going to be going through the workflow, certainly with the advent of RTK-enabled drones within the industry. And a lot of people use them, obviously, in the UK now. I'm going to show you that workflow of how to put the data in, transform it into true OS with OSTN 15 height datum, and process that through to get the deliverables out. So there is a little workflow which either some of you probably have heard of before, some of you have not, where we actually have to take the data out of Pix4D, do a transformation through it, and then re-import it back in. And this is if we're not using or we're not tying into ground control points. If we're tying into ground control points on the ground, then Pix4D will scale and orientate that model to them and tie into them. But if we're using an RTK-enabled drone, where we're using points on the ground as mere checkpoints, we have to take the transformation out. And I'm going to show you how to do that today. So I've probably spoke to quite a few of you on the phone before, or we've probably met in person, but my name's James. I'm the Business Development Director for Survey and Construction here at Copters. And how do I find myself in front of you today? Well, I did surveying and mapping science at Newcastle University, and that's basically where I came in contact with drones and used it in my final year dissertation for coastal monitoring. After that, I left university and worked as a dimensional control surveyor for 4 years, and that's really where I cut my teeth in the survey markets. That's really one good thing about ourselves at Copters. If you do decide to buy something from ourselves, you do have that years of experience and knowledge working in the survey field, which I can then pass on to yourselves. And then I joined Copters in November 2017 to basically help support businesses who want to use drones within that field of expertise, and I can help you with that. So that's my role here at Copters. And if you've got any further questions or anything you want to ask, please put your questions in the tab at the side, and I'll answer them for you at the end. So what makes Copters great as well? Just a quick run through. We are committed to the survey industry, and what do I mean by that is we have many products which we can provide for the survey community. So in terms of our partners at LiDAR USA, we do the hover map system, obviously Pix4D, which we're here today, and also Phase One Industries. So I've just had a note saying that you can't see my screen at the moment. I do apologise. Hope you guys can see that there. Luckily, it's just the boring PowerPoint bit at the start. So yeah, so we're just with our partners at LiDAR USA. We offer with the Emerson hover map system, which is a brilliant LiDAR system as well. Pix4D, Phase One Industries, great, best cameras you can possibly put on drones with the IXM series. Wingtra VTOL system. Obviously, I'm sure you've heard of DJI, and many of you operate DJI drones. We also sell RTK licenses. So again, our RTK licenses use all the Ordnance Survey base stations. We are a Parrot reseller, and also we sell the Flyability NEOS 2 as well. So I'm going to go now on to Pix4D. So some of you have probably used Pix4D before, or dabbled in it, I suppose, or even maybe even produced some data from it as well. But I want to show you how I do it and my workflow today. So first of all, this is Pix4D Mapper. You'll probably know also that Pix4D do a whole host of programs now. Pix4D Mapper being, I suppose, their default or their flagship product for the survey industry. They also do things like Pix4D Survey. Pix4D Survey would be used in collaboration with Pix4D Mapper, so you could process your data in Mapper, export it into Pix4D Survey, then use that for creating any DWG files or extracting any data from it. They also have Pix4D Matic, which is kind of designed for large-scale mapping areas, and it's faster processing speed than Pix4D Mapper. And they also have some various other smaller products like Pix4D React and a few others as well. So first of all, I'm going to open up Pix4D, and I'm going to start a new project. So first of all, I'm going to save this where it needs to be. So I've got a folder here, and I'm going to import my data. So the data we're using today is from a Phantom 4 RTK, and it was up from an old landfill site. So it's quite a big file size. It was split over 4 flights. It's about 50 acres, if I remember rightly. And I'm going to add all them 4 directories into Pix4D. Now, some of you are saying that, well, actually, you should probably process them individually and merge the data at the end of it. I've tried that before with Pix4D, and it's caused like ghosting in some of the areas. So I like to just put all my data in and let Pix4D work it out. So first of all, when we've imported our data, we were meted by the image properties screen. So you can see here that it's recognized that the coordinate system used is WGS84. It's recognized all the geotags which were embedded in my imagery, and it's brought up the camera model. So that's great. So we can see down at the bottom that we've got all our images, we've got our lat and long, our altitude, we've got our estimated accuracy in the horizontal and vertical, and we have our values derived from our IMU, so essentially from our your pitch and roll. So you could press next now, select output coordinate system as Ordnance Survey, and it will put it into that transformation. But from our experience, the transformation into OS is slightly off and not really good enough for survey application. So we have to take this data out and we have to process it in another software. So good news that the software is free. You can download it from the Ordnance Survey website, which I'm going to show you here. So if you just go onto the Ordnance Survey, or I just typed into Google Grid Inquest, and it brought up the first one, and you want one of the Windows 164 or 32. Now, this is the software, the program we're going to use for actually converting our WGS84 data into National Grid. So how I do that, so I'm going to show you the workflow now. It does look a bit complicated, but it's really just good data management, and I can guarantee once you've done it 3 or 4 times, you'll be well aware of it. So first of all, I need to extract these geotags. I need to save them somewhere in my folder. So I'm going to go to Export To. And I want all this information here. And I'm going to save it in a location. So I'm going to just call this here. So this is going to be the export from Pix. And you can call it what you want, but I think if I call it this, then you can probably follow it a little bit. So this is just export from Pix4D. It's going to save that as a text file. So we can go yes. Okay, and that's extracted all that information. So I'm going to come out of Pix4D for a few moments. I'm going to find that file here. So all I've got here is just all my exports. So you can see here I've got my image name, lat long, and some various other information as well. So I'm going to copy all that. I'm going to drop that into Excel. Now, so here we go. So I'm going to turn that into columns. And there we have it. So we've got now neatly in our columns the image name, lat, long, height, these estimated vertical and horizontal accuracies, and our IMU value. So I'm going to save that now as a CSV. So I'm going to call this, so this is what I'm going to be basically importing into Grid Inquest. So import to Grid Inquest. We go, change it now, so I can come out of that. And now I can actually open Grid Inquest itself. Grid Inquest is not a scary program at all. It's quite basic in its functionality and really easy to use. So if you did want to just transform one point, you can by doing it here. But we want to do obviously a bulk process. We've got about 400 images there. So we go to File, Load Data Points. So I've just been told that you can't see my Grid Inquest in 2 seconds. I'm just going to come out of that. Hopefully you can see that now. Perfect. So this is Grid Inquest. You can see it's not a daunting program. It's quite basic in its approach, but at least if you are transforming this data, it's very easy to follow. So you can just transform a single point, the end of these coordinate systems to OS here. But because we've got obviously maybe 300-400 images from our drone, we want to do a bulk process. We go to File, we go to Data, and then we find this here. So that was our file, which we've just created in Excel, transformed it to a CSV. Now we're going to import it into GridInquest. We open that up, and here we go, because we see all that list in here now. So it's just a little bit of data management here. So we'll start off on row 1. So that just drops it down. So the coordinate systems is basically ETRS-89 geodetic, which is very similar to WGS-84, but essentially with ETRS-89, the difference being is that we imagine that the Eurasia plate is fixed and in essence not moving away from the Americas. This just makes it easier in terms of the transformation. So we've set it to ETRS-89, and we're just going to marry up the columns here. So we've got column 2 is our lat. We've got column 3 as our longitude, and we have a vertical, right, which is going to be our 4. That's all nicely all married up there, and we want to be obviously transforming it into OSGB 36 and OSTN 15, which we haven't like that. So you can save that if you're going to be obviously doing this a lot. You can save that them settings, so each time you upload it, it will be in there ready to go. So I'm going to go OK. So it's found out where we were. So this was in Blackpool area, sort of near the airport there. And I'm going to go transform. So that's always a good indicator that straight away that you're in the right area. So when I go to transform now and scroll across, you can see here that it's given me now the easterns, northerns, and height from our lat long. So I'm going to save that now. And I'm just going to call this exported from grid. Save that, close that down. We're done with that now. So I can open up that file and show you what it looks like. So this is exported from grid. And here I have all my files. So these are the ones it's created, this transformation. So now I don't need these 2 files. So what I'm going to do is basically just override the latitude, longitude, and height. Because the good thing is, because I've exported this directly from Pix4D and used it in its format, I don't have to start reforming it and changing columns around when I'm re-importing it in. So all you have to do is delete M, highlight these 3. We're going to drag them over and just overwrite them here. So now I've got my image name, easterns, northerns, and heights, horizontal and vertical accuracies, and I've got my IMU value. So I can save that now. Now we're ready to put that back into Pix4D. I'm going to close that down, go over to Pix. So I just have to close this down quickly. So I'm just going to reset this up. So my files. Next. There's a few things now we have to do when we re-import the file back in. And that'll just take a couple of seconds. Right, so back where we started. So we're going to change our coordinate system. So what we've got to remember is we've already done our transformation outside the software to put it into OS. I'm going to re-import it in here. So we need to tell Pix4D that our data now is going to be in British National Grid. That's this one here. And the most important thing you have to do is select your height as arbitrary. And we click OK on that. So we're also now going to import that file which we've created. This one. No, it will be exported from grid. And OK. So you can see now that it's updated into the X, Y, and Z of British National Grid. That's next. At that height. Next. So most times, obviously, you guys, when you're actually doing proper work with it, you'll be either selecting the 3D maps or model. But sometimes what's really useful about Pix4D, if you are in the field and you've driven a fair way to get there, using the rapid and the low res version just to check that data in on site is a really good habit to get into, because you don't want to be traveling back to site just because of some of the images. It's one of the key things people fail to do is when they're on site, just check the data before you leave. The worst thing and the most expensive thing is returning to site to collect data, which for the sake of 5-10 minutes in the field whilst you're there, you can check through it, make sure that it's of a good quality. So I'm going to click 3D maps. Most times it defaults to this as ticked, so we can untick that and go to finish. And that's good. So again, good indicator that we're actually in the right area. So you can see this was a fairly big site. It's probably about 50, 60 acres. You can see how I've split it just to make sure there's that adequate overlap between the two flights. Now, I suppose it's been a fairly large site for a little Phantom 4 RTK. Did have to come back for a couple of battery changes, hence why there's 4 folders to this. But you can see around about there, that's the sort of overlap. That's probably too big. Didn't probably have to go that far, but just because of the nature of the site, I thought, well, why not? Easy split, sort of split into them 2 squares there and collecting the data. So I'm going to untick 2 and 3 and just keep the initial processing there for the first. So if I go to processing options now, there's a few things I do in here. So first of all, for your resources, I always just knock them down a couple. Main reason being, I've had it before where they've been maxed out and Pixel4D's frozen, and I'm not quite sure, if it's really, because obviously this is quite a lot of data to put through the process through on your computer. So just knocking it down, I always tend to find that it doesn't then fall over itself. And then on the initial processing side, on your calibration method, I change it to accurate geolocation orientation. That's purely because I know that I had a full fix from the RTK solution on the Phantom, so I can change this. Now, this does improve, not necessarily accuracy, but for that initial processing, it does speed it up quite considerably by changing that. And I'm going to click OK. So from there on, I can basically press start, and that initial processing side, what that's going to be doing, it's going to be using the pixel matching from the flight runs, and it'll be putting our imagery into 3D space using the coordinates and using them I and mu values to position that imagery. Now, obviously, that's going to take a long time, and I wouldn't expect you to hang on there to watch me process. So I've made one earlier. So here's one I've made earlier, probably the better solution to say for that. So I'm just going to discard that and reopen up this one. So this is one which I've processed through. So you can see now what Pix4D's done. So the 2 different nodes here is where the imagery originally was or thought it was, and where after it's done this initial processing, it's moved it to. You can see, because this is an RTK-enabled drone, and we know the position of these coordinates, the accuracy-wise, are probably going to be as good as 50 mil. After it's gone through that initial processing, it's not really moved the imagery too much. I'm going to show that a bit better there. As you can see, yeah, from the green to the blue to the green, it's not really moved it too far. Yeah, and you can see it's for some reason kicked out one of the images. I imagine that's probably because there's some pixel moving, or it's just come up as uncalibrated there. But that's fine. That's nothing to worry about too much. So what Pix4D then does is it creates this sparse point cloud. So that gives you some something to work on basically for it. So one thing I do straight away is which I see a lot of people don't do this. I create a processing area. So there's one thing why this. Well, there's 2 reasons why we do that. So if I go to this processing area here, and I basically think, well, actually, I don't need the stuff outside here. So I'm going to cut that out. So what that does is it just processes the area within that box. So you can imagine if you're doing let's say a large site, and you've got some stockpiles on it, and maybe the stockpile is the most important thing. It's time critical. You need to do that. Well, you can just cut that small area out, process it through to the point cloud, and start using that. Then come back, increase the processing area for the full data set. But also, I think the most important thing, it makes the data look a lot neater. So if you're then going through the full process and creating an ortho mosaic at the end of it, your ortho is going to look nice and neat and regimented and cut. I see a lot of ortho mosaics with all the jagged edges. It just doesn't look very neat. So using something like the processing area, we can do that and make it presentable. Also, that we are going to save a little bit on the process side, maybe not so much on this kind of location. We're only cutting the sort of the outside perimeter off slightly. But if you imagine, with drones and sometimes if we've got the camera and a oblique angle and this sparse point cloud's got a lot of data outside of it, well, we think we don't need that process. We can just cut it out. So the process now is a really nice tool to use for that. So you can see now I've cut that down. Now, what I need to do now is add my ground control points in. So we go down to this GCP manager up at the top. We're going to import our GCP. So it's already recognized that I'm in OS. And I know this is my GCP file here. It's going to pop them straight in. So with this being RTK enabled, then I'm really going to only use these points as a reference, as a check. So that's why we call them a checkpoint in this case. So I can right click, edit all types. That's a check. So what that means is when it goes to the next processing stage, or if we re-optimize it and pull the survey report, it's not going to use any of these points in the processing. It's going to keep them as nothing more than a check. So we can look at the deltas in the X, Y, and Z and see, well, actually, how accurate is our data? It's a really good indicator. What I would advise, though, afterwards, and certainly from the recent case studies we've done, after you've processed it through, if you do then check all your checkpoints and you think, yeah, they're great, by turning them onto a GCP afterwards, vastly improves the Z accuracy. I know one company who was doing this now, it's part of their workflow. So they'll do this, they'll put in their points, they'll use them as checks, they'll go through the data, make sure that all the residual values are there, and then turn them into GCPs. It just improves that Z. And they was getting around the 40 mil in the Z in some applications after checking. So you can see here that it's dropped checkpoints in here. Now, really good indicator. So bear in mind that obviously we've got the RTK turned on, and these points were just surveyed in with a smart rover. You can see that they are pretty much bang on there. So there's two ways now that I can start basically saying, right, I know that's that point. So this should pick up one point. This is TAR 4, and this is where it believes the center is, and it's pretty much bang on. So I can just go through now and start saying, yeah, that's fine. Now, one thing to remember with Pix4D, when you're using the zoom function on it, the further you zoom in, the more weight it adds to it. It's basically saying, well, if you've zoomed in further, you can find that target. You found the center of that target more precisely. Also, if you hover over this and press spacebar, you can bring up a bigger version of it as well. And then click on the center and spacebar out of it. So you want to do a few of these, just so that when the data, obviously if you've done about 3 or 4, then it's put in the green target, sort of the estimate where it is, and you can just fine tune that. Well, me doing 3, 4, 5 and adding a couple more in there, it kind of knows where it is now. And for me to go through and add in all them, it makes no difference really. But there is a nice little tool here called automatic marking, which if you click on it, it will automatically do that for you. Now, I still, being a bit of a pernickety surveyor, I still check through them just to make sure that it has found it. So it's done the automatic marking, and I just have a quick scroll through just to make sure that it's found it. And if there is any which you think that's probably not found the center, you can hover over it with your cursor, press delete, and then that removes it from it. You can click apply. That's that one done. Click on the next one here. Pretty much found it. Do a couple more. So the thing we'll be looking at when we're doing this, so you can see you've got these values up at the top. So the things you want to be looking at is this error to the GCP initial position. So it's taken that point we've put in from the GCPs, and it's basically comparing it to where we say it is. So these are fairly typical. Actually, sort of 16 mil, 15 mil, and 48 mil in Zs. Obviously, your Z's always going to be the worst, but they are fairly typical values. We can accept them for it. And then apply. So we'll go around our full site doing this, picking different ones and finding the centers. And click and apply. So there's 2 options we can do. We can either run the survey report, or we can re-optimize it. Now, what we do when we checked our residual values for a checkpoint, that's great. And now, as I suggested earlier, what we can do is actually say, well, actually, they're good. Let's time in and use them ground control points. So we can go back up to our GCP manager and right-click, edit types, and select that down to 3D GCP. Okay. Or we could do the drop-down target. I click on that. We can select it on the drop-down menu here. As long as you apply it, that's fine. So that one's not been done. I'll just quickly do that one. It's again fairly, 10 mil, 21 mil, 23 mil, all good. Happy with that. So when you've given Pix4D some information, like we've said, right, use these now as GCPs. We want you to take that data, take the input we've done, and use it. So I've gone through that. So then I go to process and then re-optimize and click OK. So that's basically going to use that information we've given it and then redo an output on the side. So that might take a couple of minutes to do. And that's really it in terms of the processing side. So after I've re-optimized it, I can generate the report. We can have a quick look at the report and see what's in that. I probably run it. No, that's not it yet. So we'll just let that re-optimize and I'll run the report. So I'm just going to show you a couple of things in the processing options as well. So that's the initial processing. We've done that. There's a few little options there. So the big thing which I always get asked, how do I make my processing faster? We know we can collect mass data capture at speed via drones. The main thing is time then with the processing. So I always find the main thing people make a mistake for is they start processing and exporting all the deliverables, even though they might not even need it. So things like, the exports with the point cloud, we've got the mesh, and these take a long time to process. Certainly the mesh does. So my argument is that, well, if you don't need the mesh, don't process it. So we can untick that. Thanks, Tom. And we can also then choose the output file we need from the point cloud. So fairly typical and universal point cloud formats are the LAS and the LAS format for it. I'm just going to turn my camera off. I'm sure you're good there. So yeah, most of the things you'll be using a point cloud to build up from or extract information from. And the same again with the DSM. So obviously the thing which takes the most time with the processing would be your ortho mosaic in your DSM. So again, if you don't require the DSM, untick it down here. You don't need it. So you might save yourself 2 or 3 hours of processing. Come and use. I'll probably, whilst that's doing, just see if there's any questions from you guys. So we're sharing for a moment. Cool. Right, let's go. So Neil, I just saw one from you, Neil. 2 seconds. So Neil, about the transformation from Pix4D. It's something which is fairly typical we see from any kind of software. Basically, like Pix4D, they do have this OS transformation in there, but it's not very good. It's something I've seen no end in other softwares as well. They don't have this full OS to OSTN transformation. It's not too much of an issue when we have something like GridInquest to be able to help us with that. It just is. I appreciate it's just an extra step we have to do, and we don't always want to. We don't always want to do that, but unfortunately, we have to do it. Let's see some more questions. Oh, no questions. If anyone wants to fire anything at me, by all means. Is it necessary to transform coordinates? It depends what coordinate system you're working in. Typically, obviously in the UK, we'll be working in British National Grid. So a client might obviously request, well, if you're giving us some data, we want it in the coordinate system. Or typically some sites we work into a local grid as well. Neil, you've encountered it in GI software. Yeah, so have I as well with it. It's I don't know if it's endemic just to the UK or it's similar in other countries, but yeah, we seem to have to always do that transformation for it. So I'm just going to see if that's finished the process. No, it's still going. Isaac, how's it going? Is it easy to geolocate the data if the RTK isn't used? No, it's the same workflow in Pix4D. So if you don't have the RTK turned on, what you'll see is a big difference. So from them small little nodes, when it went from green to blue on the imagery, you'll expect a big shift. I mean, typically if we're using a non-RTK enabled drone, the positional accuracy might be anywhere from 2 to 5 meters. So what will happen is when you put it into Pix4D, it'll be quite a way above Then when we're tying it into some GCPs on the ground, it will drop them. So you'll see a movement in the X and Y, and you can see a considerable drop in the Z. Sometimes what you might find if you are using something like using a non-RTK enabled drone and you're putting in ground control points, Pix4D might not find where them points are because there's such a vast difference between the two data sets. So what you do with that is you'll see there's a basic editor function on the GCP manager. And what that'll just be doing is you have to do it a bit manually at the start. So what I say, if you just select 3 ground control points, select them in 3 of the imagery and apply it, re-optimize, and what you'll find then is then your GCPs will be dropped or heightened and fit onto that sparse point cloud, and then you can continue the method I've just shown you on the faster GCPs of selecting the middle and make it large and find it like that. How long did the initial processing take? I'm not sure because I left it overnight, but I think it took, when I did this properly, it was probably about an hour on my computer. Now I've got like an entry-level gaming laptop, so I've got about 16 gig of RAM. It's an i7 processor, so that was about I think it was about a fair amount of imagery on that. So that's 1,300 images. So that's not 1,300 images on that. So that's not too bad. About an hour and a half to do that initial processing on that. Question about data outputs. Hi Zara, Pix4D, DTM, DSM, Ortho. So yes, you can produce them in Pix4D and export them out. Obviously, them final ones are going to be your take the most time to process. So what you have to do when it comes to, say, producing the DTM is from your point cloud, and you'll see that's why Pix4D breaks up the processing. So if I share again and turn the camera off. So you see this is where Pix4D splits the processing into 3 sections. So we've got our initial process. So in between 1 and 2 is basically where you're going to make it survey accurate. So you're going to put in your ground control points, you're going to re-optimize, you're going to check that survey report. Do not click 2 or 3 until you're 100% confident that that data is accurate and you can work on it. Because once you've done 2 and 3, if you find any mistakes, you're going to have to go right back to between 1 and 2, correct your mistake, and then rerun it. Appreciate this probably take 5 or 6 hours to process through 2 and 3. You don't want to be doing that when you've got a client breathing down your neck wanting data quickly. So I would say take that time between steps 1 and 2 to really make sure that your data is of quality. Make sure that it's survey accurate. Make sure that you're happy with them ground control points for it. And then once you've done that, you can start the point cloud. So when you've got your point cloud, if you want to create, a true DTM, so removing things like the buildings and the houses, there is an editor you can use, a point cloud editor in it. So you can start extracting the buildings out. You can start removing the trees. Now, what Pix4D will do is, for example, on a building side of it, when you've exported that out, it will interpolate from the known areas and points and basically draw a line or a level across it. So it will give you a flat surface then. So you've got to appreciate in some of these, that's fine for sort of buildings and that. But if you're doing a large area, that's a lot of interpolation from it. So it's just something to be aware of. But if you did want to create a DTM, that's great. You can use the point cloud editor, or you can just export the DTM, DEM from it, should I say. So that's done the re-optimize. That does take a fair bit of time. So I'll just quickly generate the report. Side it, we can have a quick look at that and go through it. I'll just see if there's any more questions whilst I was doing that. How does one set up a flight path for Pix4D vertical facade and showing distance from building when flying automated? So that'll be using a flight planning software for doing something like that. Now, you can put vertical data sets in Pix4D. I've done it quite a few times, or flying a building with an oblique angle on the camera. You can do that, no issues. And Pix4D will handle it no differently. What you'll find with Pix4D is in the processing options, it'll actually recognize that it's not on a grid. It will notice it's something like a free fly for it. So you can probably say what flight planning apps can I use for that? So I always recommend one called Hammer Missions, which does allow facade surveys. You can almost set an offset from the building front, and the drone can fly up remove and do the building like that. Really, really useful. It is a pay flight planning software, but considering the power of it, it's well worth the money. One from Paul. If you don't use GCPs, is the relative accuracy just going to be... Oh, someone else told me 2 seconds, Paul, sorry. In terms, if you don't use GCPs, is the relative accuracy still just as good? So from an RTK-enabled drone, it would be. So the thing about RTK as well is not only is it a time-saving device, but the integrity of the data within itself is much tighter from it. So we've got to remember, so yeah, it'd be improved relative or very good relative accuracy, but the absolute accuracy will be off because we haven't got necessarily drag control. But the most important thing from when we're using RTK enable is that we have them checkpoints on the ground. So typically speaking, like you said, Paul, if you want to just get some data and take some measurements from it, fine. But in terms of survey applications, if you want to issue data, we have to put them checks down on the ground to make sure that our data is good quality. We don't want someone to sue us, basically. From Laurie, in terms of processing, what minimum PC spec would you recommend? With 8 gig of RAM and a pretty good processor, it still seems to take a while. That's right, yeah. I mean, certainly if you've got RTK-enabled drone and flicking that, the calibration method to the accurate IMU and geolocation, that will improve the processing speed for that side of it. I think the only thing to save time would be to maybe not process all the deliverables through or select which ones you need for it. Pix4D do give a minimum and the recommended requirements. If you just type into Google Pix4D Mapper computer requirements, there's a whole section there on what they recommend. They'll also give you a breakdown on, okay, right, if you're processing this amount of imagery, we would recommend this. If you're doing 10,000 imagery, we recommend this. So it's something to look into. But unfortunately, just with the data sets, images are very heavy. Certainly if we're using it, large sites, that is going to be a slow process. One from Simon. We operate a M210 with X30 and X5S cameras. Can we expect to see decent results with this equipment? Yeah, you can. I know guys have used the X5S camera quite a lot. There's one thing just to remember with it, and I'm sure you guys have heard it before, is a thing about a mechanical shutter and a rolling shutter. So Pix4D does have a rolling shutter compensation in it. If anyone doesn't know what a rolling shutter is on a camera, basically if you're flying, it works a bit like if you had a photocopy and you started moving it. So when it's actually taking the images, it's because it's moving, it's stretching the imagery out. So when you put it into Pix4D, it does actually use a compensation and almost squishes it back together. So for survey applications, we tend to sort of say, well, actually, a mechanical shutter camera is better. And certainly from a traditional standpoint, old school photogrammers will always tell you the same. Something like a Phantom 4 RTK has a mechanical shutter, and it's really good for that. In Helios 2, it's a different story, I think. So, yes, so you can put Helios 2 imagery into Pix4D, and we've done that before. You can download a camera model from Flyability for that, and you can make some fairly okay models. I always say, the Helios 2 is an inspection machine first, and that you can use it for sort of modeling applications. But yeah, inspection first. So let's have a look. I've been trying to get a 3D point cloud for my drone images, but I cannot get it fully completed because it says half the cameras are uncalibrated. What do you think is the cause of this? So could be a few reasons for that. Why it's uncalibrated. You can see, you saw on that data set I showed that it kicked one of the imagery out. I imagine it didn't conform to how many matched pixels it's found. So if it doesn't conform to that ruling, it will kick it out and say uncalibrated. It might be that you haven't got enough overlap between the two images. That will say it's uncalibrated as well. There is a feature you could try and add some manual time points. That's very similar to GCPs. But we're actually saying, well, if I know there's a feature in one image, like say a corner of a table, and I see that feature again in the second image, they're the same, merge them together. So you could use that again to if you wanted to improve some relative accuracy as well. Without looking at it, Marina, probably difficult, but there are certain ways around it. You'll find, say, for that kind of data set I've showed you, where there's that, if it's a really windy day and a lot of them trees moving, obviously when you process that through in Pix4D, it might struggle to match them just because obviously the leaves are moving around. From James. Hi, James. What processing setup do you recommend for capturing trees in point clouds? Very difficult, like reduce the number of matches. We can we get asked to collect point cloud data of a site, and there's always problems with trees. Yeah, it's good question, James. I get this asked quite a lot. You could reduce the matching count. That's probably your best chance of trying to get it to fit for it. So yeah, that's probably what I would certainly suggest to someone, and someone asked me to do that. Yes, Pix4D can handle multispectral data as well. They do Pix4D field, but certainly you can put it through Pix4D Mapper as well. Mark, is this session recorded? It is. You'll be able to view it to your heart's content. I'm just going to look at some data. So hopefully, here we go. So we've got the quality report now. I'm just going to go through it and take a look. So share my screen. Right, hopefully you can see it now. So we've got our quality report up now. We just have a quick look through this and see what we're looking at. So we've got a bit of metadata at the top, what camera model, and we've got the average GSD from it. So it's about 1.5 centimeters, which is, for that particular job, we was flying at about 60 meters. So it's around about there, and that's a good indicator. So straight when we open this up, we know we've got 5 green ticks, so we're on to a bit of a winner already. We know this data is going to be good, but we just need to do a little bit of checking around the outside. So this is your key points and matches between it. It's basically found that the images are calibrated, and the camera optimization. So we look at the camera model. So what this means is, on that initial screen where we put in our image properties, it said there was a camera model there. So you'll find with, say, the Phantom 4 RTK, DJI say that they've been calibrated essentially to a certain degree. So how I explain this is that basically for that particular camera, it will be, its focal length is say 8 mil. That's unique to that particular drone setup. I always say a good way to explain is if you line up, say, 5 Phantom 4 Pros, they'll all have the same camera model. If you lined up 5 Phantom 4 RTKs, the camera model will be slightly different just because it's been calibrated and that's been embedded in the camera itself. So we can look at how good that original camera model is and what Pix4D's, if there's been any alterations to it to improve the model, how many matchings, and also georeference. Now, if you don't use any ground control points and you did select them as just checkpoints and carried on through the process, this will come up as orange here. So you can see that this is the area, image positions, and there's not been much movement because, as I keep banging on about, this was RTK enabled, so the positions fixed for it. And the main things you want to be looking at. So I tend to go straight down to this camera model area here. So this is them initial values from that camera model. And how much after the processing has it changed it, or has it thinks, well, actually, probably it's maybe not that focal length. So you can see here, 0.1 of a mil change, and that's fine. That's why we've got the green tick next to that. There, and then these are the distortions here. So the uncertainties is giving you a differences between the two. Absolutely fine. So that's just an interesting thing I always tend to look at. These are our key matches between the images. And then always the thing which we always look at as surveyors is our ground control points at the ground, how good they are. Now, things to take from this is we cannot extrapolate from this and say, right, God, my controls is good to a couple of mil. My model must be as good as that. It's not. It's purely an indication. We can say with a certain degree of confidence that, yeah, the data's good. It's going to be in that position somewhere. But we certainly can't start looking at these mean average values and saying our model's as good as that. It's just not true. It's only as good as first of all the imagery we collected, the equipment we use, and also remember it's something like, for these ground control points we put down, there might be a 30-50 mil error in that. Well, how can our model be any better than that when we've already started off with that 50 mil error? So once we're happy with these, then we can go on to the next step. So you can see if I go back. So this is something that sometimes happens with Pix4D. You lose your main screen. If you go back to your map view and then jump back in it, it brings it back up for you. So the last thing I'm just going to show you, I did mention it slightly earlier, is your manual time points. Your manual time points are similar to ground control points, but they don't have any geo-reference data allocated to it. And sometimes we can improve we can tighten up a model a little bit by using manual time points. So how we do that is we select on the sparse point cloud. That brings up all our information here, and we can select this tool here called a time point. So I can press triangle. Again, we want a feature which we can clearly define and see very easily. So something like, I don't know, a corner of a building is normally pretty good. So I'm going to select that there, and I can select it on another one. I can't remember which one I selected. Oh, can't see it in that one. So I picked the only image I can't, so let me delete that one and start that one again. Oh. Take time point manager. Let me select just the corner of that there. Straight away, it should. Move it in. Found them there, so I can just toggle that a little bit and that's it. And I can apply that there. So you do get some indication on how well you've done that. But that's just really there to tighten up the model. So one thing to remember is once, obviously, if I wanted to carry on through this, I put in a manual time point there. If I wanted to use that information, then I should really re-optimize the data again by going process re-optimize. So if we imagine now that we've taken the data in, we've done the transformation to True OS, we've changed our coordinate system, we've created our sparse point cloud, we've put in our ground control points, we've checked them using checkpoints, we have then changed them to a ground control point, we've re-optimized it to use that data, and then we've also put some manual time points to make it a little bit tighter as well. So this will be at the stage now, whereas once I've checked that survey report and go, right, I'm happy now, I can then click point cloud and mesh, and I can start the process going, then produce the full point cloud, and then I can actually then, if I did want to create a DTM, start editing the point cloud using this tool at the top. Once I'm happy with that, then I can really click the last button to create the ortho and the DSM. Well, that's really it for me. I'm going to hang around, see if you guys have got any further questions for myself. Let's just take a look. So would a bigger overlap increase overlap in the tree areas help with the tree issue? Not so much. It's very difficult to pixel match moving objects, really. That's it. So I don't think it would help too much. But if you have tried it as work, please let me know. But I don't think it would do, no. Best option for purchasing with support? Well, Steve, me. I can help you with that. So all our products, with it being either Phantom 4 RTKs, M300 P1s, LiDAR systems, all comes with full support, over the phone support, via me, and I can help you out. So it's the most important thing. We want people to buy these tools and use them successfully, and people need that support to be able to do that. And the worst thing we want is someone to buy a drone and or buy some software and not get the full use of that or not fully understand it. So that's something we and I can certainly help you with. Let's have a look. So Graham, MicaSense sensors, can Pixel.d handle the calibration cards? I'm not sure. I'll be honest with that. I've never processed multispectral data in, but I know my colleagues have. So I'll ask when your host, Graham. Oh, James, your answer nice. I like a nice community of everybody helping each other out. Simon, do Copters provide practical training? Yes, we do. We used to do face-to-face Pixel.d courses, which I'm sure we'll be bringing back next year. So we've started doing the face-to-face GVC courses. So if you are interested or keep your eyes peeled, I'm sure there'll be Pix4D courses being put on next year. We can do one-to-one courses if you wish. If you do want to, us come down to your guys' company or site, we can do that. But obviously, we do charge for that. Graham, do you have any suggestions for viewing various outputs without having Pix4D, as it's often the case for clients? So there's a few options for yourself. So Pix4D themselves do have a cloud version, so you could either use the cloud for processing and upload everything there, or you could do use it as a viewer basically, and you can give access very easily to clients by giving them a link. They do two options for clouds. They do the Pix4D Cloud, they call it, which is just a viewing tool, or use it for processing, or you can actually use Pix4D Cloud Advanced, which does give you some tools like cross sections and other bits and bobs in it as well. Matthew, hi Matt, how's it going? Can you do another masterclass on vectorizing the data? I probably will at some point in Pix4D Survey. It's Pix4D Survey is a really good tool, and certainly with the collaboration between moving data from mapper into Survey, you get all the images with it. So if you are vectorizing, you are finding, let's say, a curb line, you've got your point cloud to work on, and you also have the imagery to work on as well. Miles, can DJI Terra do the same as Pix4D? Yes, I do like DJI Terra, and I like Pix4D. I've got a horse in both races. There's advantages and disadvantages of the two. But when people talk about processing speed, DJI Terra is very fast at processing, really, really fast, and you will find you'll get better quality meshes from it as well. And one of you guys mentioned about a viewing platform for it. I mean, if you want to look at a really good one, I use Neera a lot for hosting sort of 3D meshes. So something like I can show you. So Neera, Nira, it is the software. It's a viewing platform for meshes, basically OBJ. So you can take OBJs from Pix4D, or you can take it from Terra as well. And you can do things like this. This is brilliant. We run these at events where you can open this up on a tablet and show people data that way. Again, it's all about getting the data in people's hands so that they get the value out of it. So this was just done with a little Phantom 4 RTK. All this data you see in here is via the Phantom. My computer's on the go, so let me just close down Pix4D. Probably the internet connection. Oh, there we go. So this was all done with a little Phantom 4 RTK. And you can see the sheer quality of the mesh. There's no compression at all on that. And that was processed in, that was actually done in DJI Terra. You can see there's a little, it's always a nice feature, little owl down at the bottom here. You can see that's a very nice high-end render, which, admittedly, a bit of eye candy. It shows it, but it's a really great high-end mod. And that took me about an hour to do, to capture something like that. I could probably show you a quick, but that's a really nice one. Or you got something like a church. That loads up. So what's really nice about Neera is it's just that it doesn't compress anything. When you've processed something, you can show it to clients in its full glory. So if you merge into something like the clock tower, and this was done with a phase 1 IXM camera, so like a metric camera, the best cameras you can get on the market, but you can see the incredible detail of the faces. I mean, that looks like the real thing. That's the sort of thing I really gets me excited, is the just the sheer quality of data you can capture with drones. Right, jump back into here. So, Lauren, you've jumped in. You ignore that one, no problem. Thanks again. And I think that's them all. Well, I hope this has been an informative workflow video for Pix4D, and hopefully now that you guys can take that information, rewatch this video, and do it now. If you have any further questions, or you want to take any look at our products, then please let me know. I'll drop my email address in the chat here. You can ask me anything. We've also got my mobile number as well. For you there. So we, if you want any special pricing, we have some special offers coming up for Pix4D, and certainly with the Black Friday coming up next week, I'm sure there'll be some good offers for you. Wink, wink. So yeah, let me know. Thanks everybody for joining me. It's gone very quick. Hope it was very straightforward and understanding. And again, thanks everybody. Have a good day.